All right, so we are on lesson 16 just for a little bit. We just have a little bit more to cover from that lesson, so that's why I said like take that note sheet out. This is where we left off yesterday. If you were not here yesterday, the first part of it is recorded and linked in the slides in Schoology. I understand some of you are locked out. You just have to, and you can even do that now, message your parents to fill out, I forget what it's called, but it's like the annual agreement or whatever. It updates, I'm pretty sure, your contact information. That's literally all it is. So get that done. Previously I have sent home a syllabus, and you can actually like click the link in that syllabus, and it'll take you directly with like step-by-step instructions of where you need to go to, complete that annual update. So if you need that, you could let me know, and I'll send it to your personal email, since obviously you're locked out of your school email. But that's what you need to do. And you're still responsible for all the work that you might fall behind on if you are locked out. All right, so it's just something you have to get done. It doesn't take very long. Tell your parents to get it done. All right, either way, this is where we left off for lesson 16. You were choosing which one would result in more interest earned on a balance in a bank account. So either the green option, 1% interest calculated monthly, or 6% interest calculated every 6 months. You need to know that no money is added or removed, and that the balance is left in the account for 6 months. So that's where we ended yesterday. So hopefully you had enough time to think about it. Raise your hand if you think the green option, the 1% calculated monthly, would be more. All right, raise your hand if you think it's the yellow option, the 6% calculated every 6 months, would be more. Okay, so let's see. Would this be exponential or linear? Exponential, what's the giveaway? That it's interest and that it's a percentage that is applied over a certain amount of time. So that means so linear would be adding or subtracting the same amount each time. Exponential is multiplying by the same amount each time. Now, so here's our our exponential standard equation. Table 1, what does the A stand for? Initial amount. Good, we're getting better at that. So class, does it say an initial amount anywhere in here? Okay, Landon, you say yes. What is the initial? Okay. So there's no initial amount, at least for this problem. There is one, we just don't know what it is. So it could say the A. The B stands for what? Common ratio, which is helpful if it's like doubling, tripling, halving. But when it's a percent, what do we put in place of the B? One plus or minus R, depending on the situation. So that R would be that percentage just as a decimal. All right, now is this growing or decaying, table 2? Growing, because it adds to the amount owed. So 1 plus, and what's 1% as a decimal? Table 3, what's 1% as a decimal? Good. All right, and then to the X power, what does X usually stand for? Table 5 or table 4, what does X usually stand for? Good, so in other words, time. All right, in this particular problem, the time depends on, well, how often are they applying the interest. In the green option, they're applying it monthly. And if 6 months pass by, then what's my X going to be, table 5? Good. So if it's calculated monthly and it's in the account for 6 months, they apply that rate time. So that could be for the green option. So we could like play around with numbers for the A and C, but I can also show you another way too. So that's for the green. Now make one for the yellow. Table 6, do we know what the initial amount is? No, it doesn't say anywhere in there that it starts with something, so let's leave it as A. Table 7, is it growing or decaying? So will it be 1 plus or 1 minus? Good. And then table 8, what is this percent as a decimal?
0.06.
Good. All right. Now class, if this one's calculated every 6 months and 6 months went by, what's going to be my X? 1, because it only applied that interest 1 time. So once every 6 months, only 6 months passed, so just the 1. And that's for the yellow option. Now, like I told you, we could play around with initial amounts and see which one ends up with more, but also like think back to order of operations. So parentheses, exponents, multiplying, dividing from left to right, adding, subtracting from left to right. What comes first? Could I simplify what's in my parentheses first? Yeah, I could add this and make this 1.01. And then, yes, I could do it for this one too. Oh, sorry, forgot. All right, make this 1.06. So parentheses are all done with. And we can also do the exponent because we know what the exponent is. We don't know what the A is, but that's fine because that would come after exponents anyway, is multiplying by whatever A is. So if I throw that in my calculator, all right, so we have the 1.01 to the 6th power. We get this as a decimal. And 1.06 to the 1st power, we get this as a decimal. All right, which one is more? They're pretty similar decimals, but which one is more? The green option, that is calculated monthly, the 1%. And again, you might say, oh, but the 0.00152, whatever, doesn't make much of a difference. Well, it depends on what your initial balance is. So like, and this may be a loan or it might be an investment, who knows, but say it's like $1 million. All right, that's how much money it would be worth after 6 months for the first option. And that's how much money the second one would be worth. So which one is more money? The top one. And I'm not sure what this one is, if it's like a loan or if it's an investment. But the top one ends up being worth like about $1,500 more than the bottom one. All right, so that $1,500 could be pretty significant to a lot of people. So questions on that one? All right, so the key thing from this lesson is being able to do problems with interest that is calculated maybe at different intervals. All right, so now we're going to move on to lesson 17, which is more of that too. All right, so now the paper you picked up today is what we're going to look at now. So questions? All right, so this goal, let's find out what happens when we repeatedly apply the same percent increase at different intervals of time. Letting you know, we're not necessarily going to do every single problem on here, just enough to where I think you can do your practice, because it is a lot of repetition. I'm not gonna lie to you. So, this one's fine. I just don't think it's really that important right now. So let's kind of skip the warm up. Let's look at what's printed on your paper. And it says a credit card company lists a nominal APR, annual percentage rate, of 24%, but compounds interest monthly. So it calculates 2% per month. Suppose a card holder made $1,000 worth of purchases using his credit card and made no payments or other purchases. Assume the credit card company does not charge any additional fees other than the interest. So you guys in your group will answer this number 1, which has a few different parts. You're going to write expression for the balance on the card after 1 month, 2 months, 6 months, and 1 year. So practicing the different time intervals. So try that. Do 1 and 2, because that one just has it after n months. All right, so try those parts, since it's technically 4 problems. I'll give you 4 minutes. There was some confusion about what nominal APR means, and I've got to admit, I'm no credit card expert, I kind of am, but I never get charged interest because I pay it off on time. So I never understand oh, okay, my APR is that great. I'm gonna pay it off anyway. So I don't even worry about it. So here's what it means. It says it's the periodic interest rate multiplied by the number of periods in a year. So how this problem says that it compounds 2% monthly. So they basically did 2 times 12 months, which gives you the 24%. All right, so if that kind of confused you or changed your answer in any sort of way, that's what it means. So you can honestly kind of ignore the nominal APR part because it tells you that it's 2% per month. All right, 24 divided by 12 means 2% per month. That makes sense? Okay, so I'm no financial expert either, but yeah, that's how they apply the interest. So to make the expressions, does any table want to volunteer for the 1 month? You guys want to volunteer?
No.
I mean, I could pick a table at random, but you might all be in the same boat. So table 7, why don't you tell me, is this linear or exponential? No.
Exponential.
So then process of elimination, it must be exponential. Table 8, how do I know if something is exponential? There's percentages in it, or really, in other words, you're multiplying every time, not adding every time. Adding every time would be linear. So then table 1, using a times b to the x as your general format. Do you have the final answer for the expression, or yeah? What do you guys have? Okay, class, agree, disagree? All right, looks good. So A initial amount is 1,000. So we started with. Does the initial amount change for any of them, guys? So really, if you don't have anything down, you should know now that the initial amount is not changing throughout any of these other time periods. All right, now the 1.02. So if you're not sure where that came from, B stands for what? Class? Common ratio, which is great if it says that it's doubling, tripling, or halving. But when it gives us a percent, table 2, what do we replace that B with? So basically, how did we get 1.02? Turn the 2% into a decimal, so that would be 0.02. Where did the 1 come from? Okay, we added 1 to the decimal. So when you have a percentage, you replace that b with the 1 plus or minus r. So the r is for the percentage, but as a decimal. Table 3, would this one be growing or decaying? If it's 1.02, is it growing or decaying? Growing, so that's why it's the 1 plus. All right, if we were decreasing, then it would be 1 minus, and it'd be smaller than 1. Question? All right, is the rate changing, class, for any of these? No. All right, the only thing that's changing is the time frame, which has no effect on the B. Well, I mean, I guess it kind of does, but not in the parentheses. What does the X usually stand for, table 4? Time. So is the time frame changing each time, guys? Yes, we're looking at 1 month, 2 months, 6 months, and 1 year. So that's the only thing that's changing about this. So when it's 1 month, how many times did they apply the monthly interest? Table 5. If it's 1 month, how many times did they apply the monthly interest? Once. So then table 6, when it's 2 months, how many times did they apply it? Once. So the exponent should be 2. Table 7, what should my exponent be? Good. And table 8, what should my exponent be? 12. Good. Why 12 and not 1? There's 12 months in a year. So good. Any questions? All right. For 2, the only difference is it asks for m months. So the variable that's affected by the time is the exponent. So then you just make that m. You guys always, not always, but a lot of you get confused by that on a test. Like you'll answer if it's like 4 parts, the first 3 parts right. But then when they say m months, all you have to do is replace it as an m. All right, questions? All right, we don't really need to answer the rest of this. So we'll move on. This, I also don't think we need another example of. Hopefully you can figure it out based on the warm-up we did today. This, I do want us to look at. So, find this, it's on the back side of your notes for today, for 17. Oh, we're almost done. Okay. Okay, after. All right. Abigail. All right, so find this on the back of your notes. It says the function f defined by this equation. Highlight it. Is f of x equals 15 times 1.07 to the x. It models the cost of tuition in thousands of dollars at a local college X years since 2017. So looking at what I highlighted, is this linear or exponential? Exponential. It looks more like this, the y equals a times b to the x, than y equals mx plus b. Wouldn't you agree? Yeah. Okay. So that means you should be able to interpret every piece of this. So like, what does the 15 represent? Initial amount. So that means in this situation, the initial amount of the tuition is 15. 15 what? I don't know. $15,000. So if you're like, what? The tuition's only $15, you have to read more. It says in thousands of dollars. So whatever answer you get times it by 1,000, that's like the dollar value it was. But yeah, so initial amount is 15,000. What is it growing by? So the 1.07 is my common ratio. What percent is it growing by? 7%. So that answer is B, just so you know. The annual percentage rate that it grows is 7%. And we know it's growing because it's bigger than 1. Smaller. All right, and then the X is years since 2017. So if we're trying to find the cost of tuition in 2017, then what is X going to be? Okay, is it going to be 2017? What is it going to be? 0, because it says X is years since 2017. So 2017 to 2017 is 0 years. Make sense? Okay, so then for A, you will solve that by plugging in what for the X? 0, because that's the time frame we're looking at. So you guys figure that out. And then apply a similar method to C and B. So have an answer for A, C, and D. These we already answered together. All right, I'll give you like 3 minutes. Table 1, what is the output when the input is 0? Good. So you get 15 in the calculator, but for the cost in 2017, it is $15,000 because it says in thousands of dollars. All right. So yeah, when you put in the calculator, this is what you get, and it just says like it's in thousands of dollars. Questions? All right. Table 2. What is going to be my X in 1C? Okay, -17 is what we're plugging in for the X. Why are we plugging that in table 3? Okay, good. So it says, assume that it's been growing at the same rate prior to 2017. If X is years since 2017, well then before would be negative. So 2000 would be -17 years, right? So then you plug that into your calculator, and all the time, like when I call on people just to give me the calculation, they stare at it like they can figure it out in their head. All right, no, either you already had it calculated and you're reading it off your paper, or you're throwing it in the calculator. There's no other way, sorry. So 15 parentheses 1.07, so the -17 is this decimal. So when you're talking about what they actually paid, just kind of either in your head multiply it by 1,000 or actually multiply it by 1,000 because it's in thousands of dollars. So the cost in 2000 is $4,749 and probably some cents, but we'll leave it at that. Questions there? All right. Let's see. Table 4. If we're solving 1B and the year is 2010, what will the X be? So it's X's year since 2017, and we're looking at the year 2010. X should be -7. All right, that's what you plug in into your given equation. Although you guys should be able to create it if they gave you the initial amount and the rate. And then you plug that in, and what do you get? Table 5. Okay, good. I would probably leave a few more decimal spots just because that may or may not affect our final answer. Usually on your test, it tells you what to round to if it's specific about anything. Sometimes it's to the nearest dollar. So then if this is in thousands of dollars, then the cost of tuition in 2010 was $9,341. And then there's probably some cents we could have added on, but it's fine. We'll leave it at that. So good. Do we know what happens or how to change the X? Good. Usually they define what X is, whether it's monthly, yearly. Sometimes they tell you a specific year, so you should be able to go forward and backwards from there. All right, good. So that's all that I wanted to go over with you. The rest is actually really repetitive, but if you want to go over it together, just let me know. Otherwise, I'm going to give you time to work on your puzzle pieces. So today we finished lesson 16 and 17, so knock yourself out. We just finished lesson 17. Yes, you can